This will be one of the shortest subsections we do. We're going to be looking at the last section from the structure of atoms and periodic trends. So we're looking at periodic trends and chemical properties. So periodic trends and chemical properties recognize the role that ionization energy and electron attachment enthalpy play in forming ionic compounds. So what I've drawn here is your general periodic table. And I've also drawn electron enthalpy or electron affinity and ionization energy. So here I'm looking at the opposite of electron enthalpy energy, which is this EA. And I'm looking at ionization energy. So I'm looking at positive values. On your periodic table, when you're looking in a group, higher up on the group means higher electron affinity and higher electron affinity. So higher ionization energy, higher electron affinity. So if we take a look at this, well, let's go ahead and look at the periodic table also here over here. We have small ionization energy and small electron affinity. So here's how I want us to think about this. Let's look just at ionization energy. Ionization energy is how easy it is to remove an electron. If you have high ionization energy, it's hard to remove an electron. If you have a low ionization energy, it's easy to remove an electron. Now, let's say that you do have a high ionization energy and it's hard to remove an electron. That means it's hard to make that thing into a cation. Okay? Now, the trend in a group is that higher up in the group, it's got a greater ionization energy, so it's harder to remove an electron. In the period trend, the general trend is in a period, you've got a higher electron affinity going to the right than to the left. So that means it's harder to remove an electron and make a cation when you go to the right. Now let's look at electron affinity. Change in energy when you gain an electron. A high or large electron affinity means it's easy to get an electron. And that means it's easy to turn into an anion. So over here for electron affinity, the higher you are up in a group, the easier it is to get an electron and the easier to turn into an anion. When you look at a period, more to the right means it's easier to get an electron and easier to turn into an anion. So when you put this all together and you look at the last line of each of these, high ionization energy, hard to make a cation, high electron affinity, easy to make an anion, and you look at this part of the periodic table in the upper right-hand corner is where you have large ionization energy and large electron affinity. So these guys over here in this part of the periodic table, it's hard to remove an electron, easy to gain one. That means these guys will have a negative charge. The opposite is true when you have low ionization energy and low electron affinity. So low ionization energy means it's easy to remove an electron and easy to make a cation. So the lows are over here on this part of the periodic table. And for electron affinity, a low affinity means you don't want an electron and you don't want to be an anion. So here, these guys have low electron affinity, low ionization energy. They turn into cations. So this is low electron affinity and low ionization energy. And this is high ionization energy and high electron affinity. And so if we understand that kind of forced look at the periodic table, it's easy to see why these guys in the upper right-hand corner turn into anions and all of these metals turn into cations. So that's the end of that section. Thank you for listening.